teacher. This is Pooja from CSC B section. Here I am telling the topic of copy and write from the subject operating system. We are seeing that copy and write. Here introduction to copy and write. Copy and write is a resource management technique used in operating systems. It optimizes memory usage by delaying the copying of resources until they are modified. This method is widely used in virtual memory management and file systems. Historical background. The concept of copy and write dates back to the early 1980s. It is emerged is a solution to improve performance of memory management. COW is the short form of the copy and write. Has since integrated into various operating systems like Unix and Linux. Here we can see the memory management units in high performance processors. Next, how copy and write works. Initially, multiple processors share the same memory pages. When a process attempts to modify a shared page, a copy is created for that process. This ensures that the change made by one process do not affect others. Here we can see the process 1, process 2, process n, and so on. We can change and we can in occasion of process manager, and process manager. Here we can share the shared virtual memory. They are outgoing and incoming between the process and memory manager. And we can see the advantages of COW. COW significantly reduces memory usage by avoiding unnecessary copies. It enhances performance by allowing multiple processes to share resources. The technique simplifies resource management in operating systems. Applications of COW. COW is commonly used in virtual memory systems to manage page tables. It is also utilized in file systems for efficient snapshot and versioning. Many programming languages leverage CW for optimizing data resources. Here we can see the physical page number of disk addresses. We can see physical memory here, and we can see virtual memory here. This is a transfer from physical memory to the physical memory number of disk addresses. That is memory resident page table. And we can see the going and the virtual line between the virtual memory and the page table. COW in virtual memory. In virtual memory, copy and write allows efficient management of page faults. When a page is not modified, it remains shared memory processes. It leads to the memory consumption and faster context switching. Next, COW in file systems. File systems like ZFS and BTRFS utilize COW for efficient data storage. Snapshots can be created without duplicating the entire dataset immediately. This provides a quick and space efficient way to backup data. Next, we are moving to performance consideration. While COW, that is copy and write, minimizes memory usage, it can introduce overhead during writes. The copying process can lead to fragmentation if not managed correctly. Benchmarking is essential to evaluate the trade-offs in specific scenario. Next, COW and multi-threading. COW plays a crucial role in multi-threaded environments. It allows multiple threads to share data with minimal attention. Modifications trigger copies, ensuring thread safety without locks. Next, limitations of COW. COW can lead to performance bottlenecks when many modifications occurs. The overhead of copying data can outweigh its benefits in some applications. Careful design is necessary to mitigate these limitations in systems. COW in programming languages. Languages like Python and Ruby implement COW in their data structures. This helps optimize memory usage when handling large data sets. Developers can benefit from reduced memory overhead in applications. We can see that diagram here. Data systems in Python, built-in DM structure, database structure, user-defined database structure. We can see the limitations of this. Comparison with the traditional copying. Traditional copying requires immediate duplication of resources. COW allows sharing until modifications, optimizing both performance and memory. This fundamental difference impacts with how applications manage resources. Next, we are moving to future of COW. As systems evolve, COW is likely to be integrated with more advanced techniques. Research into optimizing COW for modern hardware continues to grow. The increasing demand for efficient resource management follows this process. Case studies. Case studies for Linux fork system calls showcase COW in action. Observation from ZFS highlight the benefits of COW in file systems. Performance metrics from various applications demonstrate COW's efficiency. We can see the diagram here. That is fetch calls, fork calls. Conclusion. Copy on write is a valuable technique in modern operating systems. It is its ability to optimize memory usage and enhance performance in high is significant. Understanding how is essential for developers and system architects like real-time operating system, applications, RTOS, and culture hardware. Thank you.